6.4, we're going to find inverse functions. Inverse means switching x and y and then solving for y again. It really just means you're switching all the x values with all the y values. The only time that we don't actually switch the variables is when we're dealing with models, which we'll see in one of the later examples. All we do in that case is solve for the other variable. I'll talk more about that later. Right now, the idea is to understand that when you've got a relation, its inverse is always the same numbers, just switched around. And it turns out that an inverse function always is a reflection across the line y equals x. Meaning if you think of that line as a mirror, notice we've got points that match up. Do some highlighting to illustrate. This point is a reflection of that point. Point way out here is a reflection of the point way out there. Point right on the axis reflects of the point on the axis. And for points that are on the line y equals x, they stay on the line y equals x. So we get this mirror image. If you think of all those dots as wet paint, as soon as I fold over that red line, all the dots will kind of put the paint onto that other spot, so you'll have yellow on yellow, blue on blue, and so on. And that's what an inverse is. Our process for finding an inverse is switching the x and y values in an equation and then solving for y. It's a pretty straightforward process. So I switch my x and y and then solve for y, which we definitely know how to do. And that's it. Next up, we're going to learn how to verify that two functions are inverses of each other. And the way we do that is by using function composition. If we do f of g of x and get x as our answer, and then do g of f of x and get x as our answer, we just verified that the two functions are inverses of each other. This is really the only time I can think of where, maybe not the only time, where you do get the same answer no matter which one you start with. You really only have to check one of them, not both. But I'm going to expect you to check both just so I can see your thought process. Make sure you know how to do that composition. One more thing to point out, F inverse is written like that. That means F inverse. It's confusing notation because it does not mean the same thing as this. It's bad notation, I know. -1 normally means write 1 over something. But when we're dealing with a function, that -1 really means F inverse. So let's take a look. We're going to verify that these functions are inverses of each other. And the way we're going to do that is we're going to find f of f inverse of x, which you should know how to do from the previous lesson. And you're going to find f inverse of f of x. And both times you should get x as an answer. That's how you know you're doing it right. I'll show my work, but I want you to pause the video and try it on your own before you look at my work. After going through that inverse process, we see that indeed we get x both times. So this function, this is a function and it's inverse. All right, remember at the very beginning I was talking about how you don't actually switch variables when you're dealing with a model. When we're finding the inverse of a model, all that means is we're really solving for the other variable. Without even reading the problem, we can see we have r by itself right now. Inverse means we're going to get L by itself instead. With that in mind, go ahead and read over this problem and try part A on your own. Check your answer with mine. Part B says, use the inverse function to find the length at which the band provides 19 pounds of resistance. So we're going to put in 19 for our resistance and figure out what our new length is, being careful to use the correct units. Go ahead and try that on your own, see if you get the same answer I do. And that's it. At this point, you can try this on your own, or you can do that later. Okay, this is getting a little trickier. It's saying find the inverse of f of x equals x squared where x is greater than or equal to 0. A lot of people like to ignore something like that. Please don't. It's telling you that x is bigger than or equal to 0. That means on your inverse, you got to switch x and y is going to be bigger than or equal to 0. You got to keep that in mind. With that in mind, let's look at our original function and then find the inverse. Switch x and y. Take the square root of both sides. And here's where I bring up that y has to be bigger than or equal to 0 again. We have the plus or minus, so because y has to be bigger than or equal to 0 on the inverse, we only keep the positive piece. So now we can graph this. It tells us to graph the original, which is just a parabola. If you draw your parabola like this, you've got an issue because you didn't use x is bigger than or equal to 0. Instead, your graph should just be the right-hand side. Now for our square root of x, this guy, we know how to graph that also. If you're not sure how to graph square root of x, you can make a table of values and get it pretty fast. Last thing I want to mention on this problem, as always, an inverse is always a reflection across that line y equals x. If it doesn't look like a reflection across y equals x, you probably did something wrong. Horizontal line test. We've learned the vertical line test to find out if a relation is a function. Now we're going to use the horizontal line test to see if a function has an inverse that is a function. Every function has an inverse, but the inverse is not always a function. For instance, if there's one over here that says the inverse is not a function, it's because the inverse looks like this. And we can see that's not a function because it fails the vertical line test. But if the original function passes the horizontal line test, then the inverse is a function. That's what this slide is telling us. So we're going to look at the function f of x equals 2x cubed plus 1 and find out if the inverse is a function. And we could graph this by hand, or we could use a graphing calculator. The focus here is not to know how to graph this. So I'm just going to show you what the graph looks like. Then you have to ask yourself, does this pass the horizontal line test? So take a couple seconds and think about that. If you say yes, it passes, you're right. No matter where I draw a horizontal line, it only goes through a maximum of one time, even at this spot where it's kind of flat. Now we're going to find the inverse, which means we take the original function, switch x and y, and solve. Go ahead and pause the video and try that on your own, see if you get the same answer as me. It's worth noting that that 2 is on the inside of the cube root. If we were going to simplify this, we'd have to do something about that. That's not my focus today, so I'm not going to really worry about it. What I mean by simplify, we're not allowed to have a cube root in our denominator. At this point, you could pause the video and try these on your own, or you can do that later. Go ahead and pause the video, take a look at this example. You've already got an equation. One hint, when you're finding an inverse model, you don't switch the variables, you just solve for the for the other variable. So you're going to solve for t. See if you can set that up, make sure you understand what's going on, and I'll check in with you before we plug in any numbers. I think this one's a little bit tricky, so I gave a couple steps for a hint. Go ahead and try to finish it, solving for t on your own. Once we've got our equation solved for t, it gives us the inverse model. And I guess, is this one asking us to figure anything out? Doesn't look like it, we just needed the equation. So we're done. Last example of this section says use an inverse power model to make a prediction. Oh, now we get to use the model from the last example. If you recall, it said T equals P over 35 to the 5.2 power. We want to know when the average ticket price will reach $58. So we remember T represented number of years since 1995, and P was the price in dollars. So going back to this, we know the price in dollars is 58. That's going to go in place of T. Go ahead and try to plug that in, finish it on your own, see if you get the same answer I do. I get T equals 13.8, but that's not quite right. It's really 1995 plus 13.8. So this happens in 2008 or 2009. I'd accept either answer. It's really 2008.8. So I'd accept either answer. That happens sometime during 2008, or you could say it happens in 2009 if you're rounding. Either way, I'm good. That's it for that one. At this point, you could try one more of these on your own, or do that later. Other than that, we are done with this lesson.